Hi! Welcome back to the second episode of See Chris Learn. Last week I talked about the 5 terrestrial worlds and the geologic processes that go into their formation. This time I'd like to go a little bit more in depth about those processes and how they work. Once again, all scientific information comes from the PDF entitled Planetary Geology, and you can find the link down below. We'll start with erosion. As you hopefully know, 3rd grade science class for the win! Erosion happens when wind or water exert their subtle wiles onto rock over time, causing it to erode away and creating cool things like rivers, lakes, and the Grand Canyon. Though, fun fact about rocks, nothing is really truly solid. Even without the process of erosion, rocks do have a tendency to move on their own over time. Over a long time. Now, impact craters happen when something impacts with the surface and leaves a crater. Pretty self-explanatory, really. They're always circular, but not because the object itself is always circular, but because the force with which the object hits the ground causes a blast radius, and so everything just sort of blows out in a circular way, whether or not the object is like square, rectangular, or oblong and weird. The most interesting part of impact cratering to me is that there's a math to it as well as, the science. The craters tend to be about 10 times the width of the original object, and then in depth they're 10 to 20% of the width. So if you know how big an impact crater is, you can actually figure out how big the object was that hit it. Volcanism happens when magma rises to the surface, erupting in a spectacular blaze of glory, or, so I've been told. Not having seen it, I can't actually say for myself. The magma generally rises because liquid rock is less dense than solid rock, but there can also be tectonic forces at work squeezing and creating pressure until the magma literally has nowhere to go but up. I kind of imagine it like one of Mother Nature's pimples. Make of that image what you will. Last but not least, let's not forget tectonics. Tectonics are the internal forces of the planet. Underneath the crust is the mantle, and the mantle moves. It's called internal convection. The convection cells, which I'm assuming is just basically the mantle, can move and drag the lithosphere, which is the ground under your feet, the crust of the planet, along with them. So mountains and valleys happen when convection cells come together or apart, and on Earth, they've literally actually broken the crust into pieces, which is why we have plate tectonics. Now, the cool thing about geologic processes is that they create a sort of timeline on a planet's surface. I'll use examples from different planets to show you how this works. If you remember from the last episode, I showed the graph of the timeline of the solar system. So, the way that works. There was a period of heavy cratering in the early days of the solar system, right after the planets were created. So most of the geologic processes happen on planets that are alive, meaning they've not completely cooled to the core. There can be no volcanic activity, for instance, if there's no magma beneath the crust. So let's take Earth as an example. It's pretty close to home, right? Earth was heavily cratered just like the other planets, but we're not tripping over craters every day on our way to work. The reason is because those craters have been wiped out by volcanic activity, tectonic activity, and erosion. Volcanoes erupt and fill the craters, earthquakes happen and erase them, and wind and water erode them away. They're gone, and it's just because Earth is still very, very lively. Now let's look at the moon. You can tell just by looking that there's still some significant cratering visible. You can tell that from Earth. But not all of it. Parts of the moon's surface look smooth, don't they? These are referred to as the lunar maria, which actually means moon seas in Latin. So what the heck is a moon sea? Basically, before the core of the moon completely cooled, something most likely cracked the surface, an impact crater cracked the surface and caused volcanic activity. So then these vast plains were covered in lava, which cooled and then created the smooth plains that you see in the image, juxtaposed with the cratering. But Chris, you say, there's a crater in that picture on the moon sea part. And you, dear internet, would be right. That crater is young, much younger than the craters you can see outside of the lunar maria, and younger than the plains themselves. That crater happened after the plains were created, obviously, and thus the timeline is created. I'll give you one last example from Venus, but before I do that, I'd like to make a point. Aside from Earth, you'll notice that erosion is not really talked about on the other planets. Erosion, as you know, can be wind or water. Water erosion requires, well, liquid water, and aside from Mars, well, there's no water, and on Mars it's not liquid. Wind erosion is, you need an atmosphere, and on most of the terrestrial planets, there's either no atmosphere or there's too much of an atmosphere to allow winds to blow, so that's why I'm not really talking about wind erosion. Okay, back to Venus. What you see on your screen right now is a picture of Kono Mons, a volcano on Venus, a really old volcano. And I say that it's a really old volcano because it has been bisected by a chasma. As you might be able to tell from the previous graph, we're not sure how active Venus is or if the core has completely cooled by this point. Either way, Kono Mons came into existence many millennia ago, and then some century or millennia after that, the sphere and chasma happened on the exact same spot. There's your timeline. Mons, then chasma. And because they happened in the exact same place, it's quite likely that Kono Mons was created with some mixture of volcanic and tectonic activity. After all, this is obviously a weak point in the surface of the planet. So hopefully that explained what the geologic processes are, as well as how to read them, how to read the timeline that they represent on the planet's surface. Now I'll move on to the mythology part of this project. Originally, I had wanted to talk about Kono and Sferen. It turns out that researching obscure African and Lithuanian goddesses is harder than you'd think. Kono is an ancestral goddess of the Senufu people from the Ivory Coast and Mali, a goddess of wild birds. Sferen is a Lithuanian goddess of the hunt and protector of dogs, similar, it seems, to Artemis. Beyond that, I'm still trying to find out a little bit more, so instead, I will leave you with the Senufu Creation Myth, which I found pretty interesting. The Senufu were Shukolot-Yolo. I think that's how you pronounce that. Not actually speaking their language, it's just a guess. Anyways, that guy is the creator. He is the one who created the first man and the first woman. As you might be able to guess, the first man and woman got a little jiggy with it, and 9 months later, the woman, unnamed, gave birth to twins. Hence, twins are very important to the Senufu people, but only if they're male and female. They represent the children of the first couple, and they also represent a divined pair. Kolotiolo is a distant god who can only be reached through much ceremony and, lots of, sacrifices and dances. Yeah, I also don't know a lot about African religions. I'm just lots of ceremony. But he actually has another aspect. She is Katia Leo. Again, pronunciation, my apologies. She's the ancient mother and much more accessible to the people than Kolotiolo is. Now, Senufu art is filled with pairs of statues that belong together, creating a pair, one representing a male and one a female. My favorite part of all this is there's this symbol that's used on the female statue. You can see the 4 lines radiating from the belly button. Those are Kunodyade. Yeah, that's just not happening. Which translates to navel of the mother or mother of twins. It's a symbol that's painted onto the stomachs of girls when they reach puberty, which is, again, just really interesting symbolism. Though why it was the unapproachable male deity and not the great mother that created the humans, I don't know. I'd imagine that's a topic best discussed by a religious studies class or maybe a women's gender studies class. So, tune in next time to learn all about the colorful world of geologic mapping. And as always, rock on and keep it classic.